All right, so we are recording now. I finally got that to work. So what's interesting is I have to use two different cameras for my recording and my like Zoom. So when I look at you guys, I'm looking at my Zoom, but I'm not looking at my other camera. I don't even know if you guys can see the other camera show up on the picture-in-picture.
I saw it. It was like I was so confused. I was like, how is it coming from two different angles?
Right,
Yeah.
but now it's gone. I don't know.
Got it at the bottom corner.
All right, everybody show me graph paper. And I should make you show me your plan book also, but I will just let it go that if you have graph paper, I assume that you have your plan book. I'm going to come back to our announcements page. In your plan book, please write down 10 new assignments in KA. Or you can really just say KA due December 7th, because that's different. You could even flip to December 7th and write KA due today, or math due today, or whatever you want to write. Those of you with your cameras off, if you can turn them on, that'd be great. If not, I assume it's some sort of internet issue or whatever else. That does not mean that I won't call on you, so please make sure that like you're ready to be called on. But guys, I'm not a huge, like, your camera has to be on the whole time. Like, what if you want to, like, take your sweatshirt off? Or, like, what? Like, I get it. So, if your camera turns off, I'm going to trust that there's a reason for that, and you'll turn it back on when you can, or that there's some kind of tech issue, or something else like that. So, and you guys know, like, I'm the teacher. I'm managing this. Don't worry about other people. If somebody's camera's off, like, they've probably sent me a message in the chat or something else. So, guys, the reason I'm making this coming due date on December 7th is now that we're back in remote, I only see all of you Tuesdays and Thursdays. So by Monday night, I'm making my final determination of what are we going to do this week. And really, I'm planning before that. But by Monday night, I'm finalizing things. And even this morning, I was finalizing what am I going to do with Math 8. So that's why we're going to say our assignments are due Monday at 5 p.m. Really, if you want to make it, just do them this week. Get them done by Friday or Saturday. You'll notice I'm not assigning all the videos now. I know that you're doing school every day now instead of one of your days being at home where, no, let's not talk about what you guys did on your at-home days. Some of you guys had work to do and some of you guys just sat around and played Minecraft, I think, which is okay because if you didn't have schoolwork to do, Minecraft is better than nothing. So, November 18th assignments, they were due. That's in the past. There's no going back in time, so those grades are in MAP now. If you were missing or check minus on any of those, they're in MAP now. If they need updated, please email me. This was from yesterday morning. So if you go in there and you're like, I did this yesterday. I printed my reports yesterday morning. I couldn't stay here because it was so freaking cold in the school. My hands wouldn't work. So I went home and I didn't get grades uploaded at home. I did them first thing this morning. So if you did an assignment yesterday, my grades might not like be 100% right. You might need to email me. If map needs updated, email me. This should be a apostrophe. Sorry, I'm not going back and changing it. Today we'll be discussing the, slope. Sorry, I never finished that sentence. That's funny. So let's just go ahead and dive in. So let's review slope-intercept form. Right, so slope-intercept form. Who can remind us what all lines in slope-intercept form are going to look like? Well, yeah, we could say all. Who can remind us what all lines... So let's go ahead and head our paper. Slope, intercept, and graphing. Today is December 1st, a nice snowy December 1st. I heard in Foundations that Mrs. Goldring put down the challenge to go make a snowman. Do you want to build a snowman? Yes, we want to build a snowman.
I was going to finish it, and then you ruined it with some weird off words.
Dude, I've seen that movie like once, and that's only because my wife says I saw it. I really don't think I did.
I've seen that movie like...
I think I fell asleep.
15 times.
I've seen it so many times.
Alright, we can only sing so much of it, though.
I was in a musical that a bunch of kindergartners put on. There were no
that's
adults.
fun.
It was just a bunch of kindergartners.
That sounds like a bad idea. Alright.
And then my best...
yeah.
Sounds like the worst idea in the universe.
Correct. Alright, let's refocus, because we got a lot to get through today. So we got to try to stay focused. I know, as hard as that is with me. All slope-intercept forms of an equation, right? We can build slope-intercept even when it's not slope-intercept. All slope-intercept forms of an equation are going to be in the y equals mx plus b form. And we should have written somewhere in previous notes, Colin, I'm assuming that you can see your screen and still take notes from however far away you are. Our m, Colin, because I'm already picking on you, what is our m in y equals mx plus b? Spacebar.
It's our y coordinate.
Yeah, that. It's our slope. I don't know if that was Colin or somebody else snuck in there and just said, it's slope. But yeah, m is our slope. And b, oh, Ben left the call and came back, I guess. B is, Sophia, what's our b value?
It's an extra number added or subtracted off.
Yeah, which tells us it is the, if m was our slope.
Proportional or non-proportional?
Yes, you are correct also, but if m was our slope and we're in slope intercept form, that means b is our
Y-intercept.
Yeah, it's our y-intercept. So if you want to go ahead and make a graph on your paper, I obviously used a ruler to make a pretty graph. If it's 10 by 10, like 10 up and 10 out, you'll be big enough for everything we do today. I'm probably going to graph a lot of our lines on this. So 1/3 is our slope, -2 is our y-intercept. A lot of times we say we start at our y-intercept, but I don't like using that word because we don't actually start. Our lines are continuous. But if we go ahead and place -2 on our graph, now if your scale is not marked, it's assumed to be 1:1, right? If your scale is not marked, it's assumed to be 1:1. And then I'm just going across the row. Akshay, how do we use our slope to move on this line?
So it's rise over run, so we go up 1 and over.
Yeah, slope is rise over run, so we go up 1 over 3 and over to the right, right? Because they're both positive. We're moving both positive directions. I can do it again, up 1 over 3. I can do it again, up 1 over 3. Now, this is one way that you can find your x and y intercepts, because now I found my x-intercept. I had my y-intercept from the beginning, and we can even go backwards if necessary. Instead of going up 1 to the right 3, we can go down 1 to the left 3. So guys, on your desk, you should keep a ruler, a calculator. Like now that we're back home, we should have our resources like a bit quicker to grab. So if we connect all these dots, that is our line of y equals 1/3 x minus 2. We've got our y-intercept of -2 and our slope of 1/3 that we could show with slope triangles if we want to. So our slope triangles would show we're going up by 1, over by 3. My hands are working better today than they were yesterday. I'm glad. So what this equation tells us, if we actually look at the question that I had prompted, is the slope is 1/3. The y-intercept is -2. Right? So it tells us two things. It tells us the slope, tells us the y-intercept. So if we look at something like this, this seemed to give you guys some trouble. So I wrote it, I typed it, but then I copied it so it was like black on white because it's a little easier to see for some of us. Why is this equation, why? Why is this equation, Logan, not as easy as our previous equation? Like 1/3 x minus 2. Why is this not quite so easy?
Because 2x is switched with the 4.
Yeah, right. Like the order is switched.
Right.
Yeah, like what you like. The x is over here, the 4 is over there. Now here's
The slope is 2.
Here's the really dangerous part. If we go to switch this back, everyone write down y equals 4 minus 2x. Another way that we could write that is y equals 4 plus what? We started with this. You don't really need to see my other screen right now. If we start with 4 minus 2x, we could do 4 plus, shout it out.
-2. -2.
Yeah, negative 2x. Guys, if I don't call on somebody specifically, you are welcome to just hit that space bar. If you didn't know this, I think we taught you this. Space bar unmutes you, right? If you're clicked into Zoom, space bar will unmute you. So 4 plus negative 2x. So if we switch it around to put the x value first, what we have is y equals negative 2x. Uh-oh, Logan. Plus 4. So Logan, I'm going to come back to you. What's our slope here?
-2.
-2. Yeah, not +2. So be careful. This is where this is a trap door. Our slope is not 2. It's -2. So if we go up to graph this, our y-intercept where we start, quote unquote, we're going to put y-intercept at 4. And our slope is -2, meaning go down 2, go right 1. Go down 2, go right 1. Go down 2, go right 1. I could do the opposite, and I could go up 2, left 1. Up 2, left 1. Up 2, left 1. So guys, notice that I'm going to color code all my lines today. What I write in will then be the color that I graph in. But if you would like to label the lines, like beside the lines, if you want to write y equals 4 plus -2x or y equals -2x plus 4, whatever you would want to write next to that line, just so when you come back to your notes and look at them again, might help you out. Now, if we're graphing lines, we found our x-intercept. But what if we weren't graphing the lines? Well, this is where I chose to plug our community help document that fortunately Kelly was ever so kind to put some work into this before break. So if I go to my community help doc, and guys, this is in Schoology. Actually, I'll show you how to get to it in Schoology. So if we go to our Math 8 Schoology, did I not link it? I didn't link it yet. All right, so I got to fix our Math 8 Schoology, but this is because I had Kelly working on it, but I need to go link it. So there's a mental note for myself. I got to go link it in our Schoology, but I promise I will link this. If I don't, somebody email me and bug me as people send me questions. So somebody sent me this question. How do we determine the x and y intercepts of this? I show you in a video how to find the x and y intercepts without graphing. So today, obviously, we can see that if we are graphing, a lot of times we can just see, well, where does it cross the x-axis? Oh, it crossed at 2. So our x-intercept there is 2. Our y-intercept is 4. For my blue line, where did it cross the x-axis? I could just count my way out there. But what if we don't graph it? You can go watch that video. Sorry, that is in the community help doc. I will actually just add it right now. I'll just do this. Here, you guys think about this problem. Well, I'm gonna drag my internet window to another screen and go add that to Schoology really quickly. Think about this problem. Now, guys, when you go to that link, you are all editors. But remember, I can see all the edit history, so please don't do anything dumb. Like, this is just me as a middle school teacher saying, please don't do anything dumb. I'll have to go and figure out who did that edit, and, like, we'll have to, like, get you in trouble, and it's all dumb. So please don't, like, you know, post anything into that doc that shouldn't be there. All right, it is in our Schoology. So this one is interesting. AJ, I'm not sure exactly what you missed. I am recording this, though, so you can always go back to the class video. Feel free to hang out later if you want to, or ask your brother or anybody else if you want to. But, yeah, I mean, just go check my video later. We really have just been graphing based off slope-intercept lines. So this line is slope-intercept, kind of? Like, so there's no y-intercept, right? Ivan, what do we do here? Yeah, the y-intercept of this line. Guys, if we think, well, what color should I use? Purple. Haven't used purple yet. Y equals 4x plus 0, right? There's nothing added on out there. The y-intercept would be 0, and then the slope is 4. So if we go up 4 over 1, up 4 over 1, or down 4 to the left 1, down 4 to the left 1, and then we connect those lines. This line, or sorry, we connect those points. This line is going to look steep, and it is steep, because the more positive our slope is, the steeper positive it is. The more negative our slope is, the steeper negative it is. So now I got to zoom out so we can see a little bit more of what's going on here. But you guys, so what do we know about this line? We know it is linear, but because the plus 0, what else do we know? Somebody said it earlier in class. We know this line is
Proportional.
Yeah, this is, thank you, this is proportional. So you can make a little note there. That line is proportional because the y-intercept was 0. Any questions on what we've done so far? We graphed 3 lines. 2 had positive slopes. The red line had a negative slope. Talked about y-intercepts. Any questions? Going once. Going twice. All right. Oh, wait, there's no slope. Y equals x plus 5. But there's no slope. What do I do if there's no slope? Maya, what do I do if they didn't give me a number?
Isn't it just 0 then?
It's 1x.
Oh, we've got conflicting.
Oh, yeah. I forgot.
Ah, Maya, so you want to change from 0 to 1? So if there's no slope, well, that's not true. There's not no slope here. The slope is 1. So this equation, I got too many windows, of y equals x plus 5 is really y equals 1x plus 5, right? We're allowed to add those things in. So go up to your graph, go to positive 5. And if our slope is 1, it's a nice boop, 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 boop. Now going back to our mastery that we took right before break, if we have a slope of 1, does anyone know what degree that makes our line? Like what degree of an angle up off the ground? It was one of the roller coasters had a slope of 1, actually. I forget if it was 1.
45 degrees.
Yeah, I heard a couple people say 90. Now be careful. 90 is a right angle. This is a 45 degree angle. So if you imagine a horizontal line and this green line, what angle it would make rising up off the horizontal line, if it cuts the box perfectly, like it has a slope of 1, that is a 45 degree angle. So a slope of 1 is a 45 degree angle. Other slopes are really complicated to convert, and that's where trigonometry comes in. So if anyone's ever heard about trigonometry, that is where trigonometry comes in. All right, so now take a moment, graph these lines, and then we'll be done with that graph. So I know it's starting to get crowded. If you want to make another one, you can. I might make another one real quick just because my other graph's getting crowded. So I'm going to go ahead and make a new XY axes to finish graphing these 3 lines. But do this without me, right? I'm talking to kind of just vamp and use some time. But graph these 3 lines without me. If you have any questions, now would be a good time to ask them since everybody else is just working. But like on topic questions, right? Guys, if you're sitting there doing nothing, just waiting for an answer, you might as well just leave the call. Like, you might as well just have me mark you absent. Remember, I can't really check on exactly what you're doing in this moment, although I may ask to collect your notes. But if you're just sitting here doing nothing, you're getting no benefit. So try it. Take a risk. Do this on your own. Double check, is your y-intercept positive or negative? Double check, is your slope positive or negative? So we already had something with a slope of 4x, but now we have 4x minus 9 as our equation. I told you guys a 10 by 10 would be all right. Now, what I hope you notice as you graph these, actually, I'm going to ask a question instead of saying what I hope you notice. What are our x-intercepts? Not y. What are our x-intercepts? Are those easy to find here? Do they hit at nice, easy, countable locations? Or are a couple of them maybe kind of tricky? Sophia, what do you think?
The one that did end up being the nicest was the y equals negative x minus 6.
Yeah.
But the other two landed kind of awkwardly on the graph because they were like halfway between points.
Yeah, these. Man. I'm going to try to get this focus to come back. I switched my focus setting so it wouldn't keep changing focus during class. So, man, if we're graphing, and the green line is my line with a slope of 4x, and I had this point right here, and I'm going to go up 4, 1, 2, 3, 4, and over 1. But what if I don't go up the entire 4, right? Because here, how far do we go up? Like right here. 1. So how far would we go over?
0.25.
Yeah, a fourth, right? So that x-intercept, if we break apart the slope, 4 over 1 could be 1 over 1/4, right? So if we say that our m was 4 over 1, but we can actually make that equal to 1 over 0.25, right? We said. So this would have traveled another 0.25 to the right, making that x value 2.25, and the y value there is 0. Try that same thing with the line that had the slope negative 3x and had the y-intercept of plus 7, so I made that blue on my graph. So if we have this point right here, and we're going down at a slope of negative 3, take a moment, try to figure out that x-intercept if you only go down by 1. Anyone want to be bold and tell me what they think the x value is there? Kelly?
2 1/3.
Yeah, 2 1/3, because if we go down 1 there, we'll go over 1/3, because we break our triangle into 1/3 of its initial size. Now guys, what you don't know right now, well, you might know this, is what we're actually talking about in this sort of situation is similar triangles. Similar triangles keep the same like proportions, but change size. So like on a computer, when you grab a corner and scale something and it still looks the same, that'd be similar. If you grab a corner and just drag one direction and all of a sudden the image like breaks and it looks different, like it stretches, that's not similar if we stretch it awkwardly. But if we scale it both corners in and both corners out, as opposed to just making it one direction bigger, that's a similar triangle. So that's what we're actually doing right there. Any questions about graphing those 3 lines before we move on? If you need to come back to this, if you need any more help, obviously I am recording. You can consult the video later. Oh man, these aren't whole numbers. So really quickly, let's graph these. I'm not going to ask you for x-intercepts on these, but I do want to make sure that we all can work with the rational values. Now, luckily, I left the y-intercepts the same. Guys, these are straight up from your Khan Academy that I assigned, like, today. So we're doing your homework together. If you're not doing this, you should be. So I'm going to make a new XY axis here just because I like to clean my things up. Yeah, I got too much writing in there. You might, if you didn't put all the writing like in the middle part, you might be able to fit this still. But I'm just going to make a new XY axis. Please graph all 3 of these lines, and then we'll check. Did you do it right? Let's at least do 1 together, I guess. Sevi, I'm going to pick on you, but also say amazing Discovery Day reflection. I will actually say, because there were multiple teachers involved in getting you guys those hearts, your Discovery Day reflection has been shared with the teaching team. So, yeah, good work, man. That was pretty sweet. So, Sevi, if I look at the first one up there, 6/5 x plus 1. So I'm at the +1 for my y-intercept, but how do I move? How do I build this line?
Go up 6 and over 5.
So guys, if this was given to you as a decimal number, they would have given you the slope as 1.2. Do you think you're going to go up 1.2 and over 1 and up another 1.2 and over? No, that would be silly. It's way easier to go up 6 and over 5, or go down 6 over 5. That's way easier than using some silly decimal number slope. So this is why I'm encouraging you guys to leave your slopes in fraction form. Now 6/5 is just barely over 1. All right, so this looks like it has a slope of 1. It doesn't. It has a slope of 6/5. For my next line, we're going to start at 8. Dewan, how do I move on my line where my y-intercept is 8? What do I do to move? It's the second equation over there on the left. How I wrote it is slightly different than how it's on my presentation. So that's kind of to give you a hint. And always, guys, you can say skip. Like, I'll always move on and come back to you. You're muted, dude. If you're trying to talk to us, you're muted. Sorry, I didn't think to say, hey, on mute.
Down 4 over 3, right?
Yeah, down 4 over 3. So down 4 over 3. Oh, we crossed that line, but not at a nice spot. Down 4 over 3. Oh, we got a nice x-intercept. Or up 4 over 3. Right? We can do what the slope tells us or the absolute opposite. Now, why was my writing different than what I had in my presentation? Computer-generated things are almost always going to put the negative out in front of the value. We talked about earlier in the year, it doesn't matter if your negative's in the numerator, in the denominator, or out front. It means there's one negative. So guys, if I think of that as being a positive 4 but a negative 3, watch my screen. Please watch my screen. If I think of this as being, let's do this, positive 4 over negative 3, check it. Positive 4, 1, 2, 3, 4. Negative 3 means go left. 1, 2, 3. Oh, hey, look, there's my point. From here, down 4, negative 4, right? Like 1, 2, 3, 4. Positive 3. Oh, hey, look, there's my point. So it doesn't matter if I put the negative on top or the negative on bottom. Just make a habit, right? My advice, put it on top. It's way easier to go down and right than it is to go up and left. Colin, you're totally good, man. I'll see you, bud.
The lines intersecting looks like a really nice X, just like in general. It just looks nice.
Yeah. Now, later in your Math 1 class, we will challenge you to say, is that a 90-degree angle? And if not, how do we know? Now, that's not what we're doing right now, but that's where you're headed in your math career, is like, how nice of an intersection is that, or isn't it? So the last line we're going to graph here, negative 3 halves minus 3. If we start at the negative 3 and negative 3 halves, we said we can go down 3 to the right 2. Guys, all you need to care about really is if it's a negative slope, it's going to be going down. If it's a positive slope, it's going to be going up as we travel from left to right. Get a few points. More is always better. To line things up, more points is always better. Kids will ask me how many points is enough, and I will say enough to make a good line. 2 points is not enough. 3 points is the minimum. 5 points is what I like to go with. So you'll see 1, 2, 3, 4, 5 points, and then I graphed. I only did 4 points here, but this line was pretty easy to deal with.
Is 10 too many?
Nah, 10's fine. On my blue line, I only did 3 points because they were going to be so spaced out. I decided 3 was probably enough. But yeah, guys, I normally try to go with 5 points. Now, here's a question you will approach very soon. If my purple line is y equals negative 3 halves x minus 3, are green and purple parallel? What does parallel mean? Who can volunteer to talk about what parallel is? Zoe? Sorry, I saw your hand move. Do you want to tell us what parallel means?
The 2 lines will never touch.
Means they'll never touch. Okay, who wants to tell me what else parallel would mean in this case? Kelly?
It means that they have the same slope.
Yeah, so do green and purple have the same slope? Well, is negative 4/3 equal to negative 3 halves? No.
So negative 3 halves is also equal to negative 1.5, whereas negative 4/3 is also equal to 1.3.
Yeah, negative 1.3, but yeah, absolutely. Good work.
So eventually, if you keep going, they will touch at the top.
Yeah, it looks like up here they're closer than down here. This looks a bit wider, and we could actually count the gap in between them if we want to. But yeah, up here they look closer. So, here's the good stuff. Sorry, that could have been loud on your end. My bad. Here's how we deal with slope-intercept when all we've been given is 2 points. 2 points. Sorry, this looked like 1. First step. Always the first step. Find your slope. Guys, that's always our first. We did this like last week or 2 weeks ago or whatever. First step is find your slope. Second step, using that slope, build your slope-intercept equation. Fraction is best, right, for your slope. But you don't know your b yet, so we're just going to write plus b. Then, and I should have split this. Then plug in one of your points and find your b value. Now, what the heck is he talking about? Let's practice. So, if our points are 1, 4, and 2, 2, I'm going to cover up everything else right now. I'm going to get a new sheet of paper. Oh, today's a lot of paper day. I can fit this on the bottom here. But it would be better to start a new sheet. So if you're labeling a new section, we're going to say slope intercept from 2 points. And our 2 points to start with are 1, 4, 2, 2. And I do not want you to graph this. So if you're still on your graphing page, we are not using that. Now I'm going to put this little arrow here saying 1, 4 goes to 2, 2. They make a line, right? Kelly, what's up? You got a question?
Oh, I was just going to say, I thought you were going to do it on the graph, and I was going to say, can't you just do it in your head?
Whoa. Can't you just do it in your head? Sounds a little dismissive. Maybe, but I'm going to write things down anyways. So you're good. You're right. This is not difficult math yet, but it's going to get difficult. So I always advise write it down. We said last week our m is our delta y over our delta x, and we talked in class about if you want, you can build the whole equation of y2 minus y1, x2 minus x1, and set up the math that way. Or this is the way I like. How do I go from here to there? And how do I go from here to there? Notice I put my y on top and my x on bottom. So my change in y, how do I go from 4 to 2? Yeah, subtract 2. Or over here, we could have said y2 was 2 minus y1 was 4, and that will get us a negative 2. How do I get from 1 to 2? Add a 1, right? Or I could have said 2 minus 1 is a 1. Either way, our slope comes out to be negative 2. Or negative 2 over 1 if you want to keep it in that fraction form. So now, here's step 2. So here, this was step 1. I should label these things. This is step 2, where we then, and I'm going to write out everything. We know we're going to fit into this form. What we know is a slope of negative 2. So we're going to say y equals, I'm going to switch colors to what we're plugging in, negative 2 times x plus b. Is anyone lost right now? Any questions of what I've set up right now? The only thing we know about this line so far is it has a slope of negative 2. And that it uses these 2 points. Now, I'm going to plug in one of the points. So I'm going to circle this in blue because I'm going to write in blue to do this. So the y value of that point is 4. I'm going to switch colors a bunch here. What's the x value of that point? 1. And the b value? Yeah, we don't know it. We're about to know it, though. Now I'm just going to write all in the same color. So 4 drops down. Negative 2 times 1 is negative 2 plus b. We use algebra to get b by itself. What do I do to both sides to get b by itself? There it is. Add to, or subtract negative 2, right? If you said subtract negative 2, that I would have let that slide. And b is what? So what that tells us then is we know our slope from up here. Our slope is -2. We know our b of 6, but now we're not using these numbers that we wrote in blue because we want y and x in our equation. So our equation becomes y equals that slope of -2 times any x plus the b value we found of 6. If you'd like to check this, plug in your other point. Do y equals, I'm just going to write everything in the same color, your slope of -2x plus b. I'm going to plug in 2 over here instead. So 2 equals -2 times 2 plus b. 2 equals -4 plus b. B equals 6. Checks out. No matter which of the 2 points I use, I get the same b value. Any questions? Oh my gosh, you guys are bouncing around. Kelly.
Yeah, I have a question. Could you, in theory, figure out the X intercept by switching slope formula or flipping it? Like if you do X, or like, yeah, if you do X equals my plus b, and then factor in those same points, could you, in theory, find the
Not just in theory, in practicality, right? So I love that you're saying in theory, but remember, when we're saying in theory, we're saying we can't actually do it. When we say in theory,
okay.
So in actuality, we can do this. Kelly, you're absolutely right. When we think back to the x-intercept, here or there, what is the y value on the x-axis?
0.
0. So guys, here's all we have to do. I appreciate you asking that because this might as well teach this. To find the x-intercept, all we do is set y equal to 0. So now that we have our equation, okay, if y is 0, then this becomes 0 equals -2 times x plus 6. I could subtract 6 from both sides, right? So -6 equals -2x. And guys, the first video in the community help document goes over how to do just this. Like literally all the way to finding the x-intercept also. -6 divided by -2? 3. That's our x-intercept. Try on your own. Okay, we're out of time. So here's what's up, because I always want to respect your time. And Akshay, I'm going to take your question in just a second. We will pick this up on Thursday, and probably the warm-up question will be one of these saying, find the slope. Actually, I'll probably say find the slope-intercept form and find the x-intercept. So like we just did right here, we'll start from 2 points. We'll find the slope. We'll then find the b value after the slope. And then once we have the slope and the b value, we can find the x-intercept by making the y 0. If you have any questions remaining, like Akshay, if your hand was actual, hang out. Otherwise, I want you guys to be able to take a break before extensions. But remember, your day's not over, right? We have school, we have extensions till 3:40. If you are not done with your Khan Academy work or work for any other class, you should be in extensions, right? Doing work until at least 3:40. All of us teachers will be on Zoom, available for you. I'm at school, so I'll be hanging out here on Zoom. I think all the other teachers are at home today, but I wanted to come in and not have my dogs distract me all day. They love to go in and out, just in and out, in and out, in and out all day long. So get on Zoom, come ask us questions if you need. If you're behind on your work, you're our top priority, right? So if you're caught up on your work or if you're working ahead and we tell you like, hey, I can't work with you today, just know that means like there are other students that need us more than you, right? So like we want to help everybody, but if a teacher says like, hey, I can't help you today, just means they got too many people. So yeah, keep emailing me questions. That community help document is on our Schoology now, and I'll see you guys on Thursday. So have a great day, guys.
Help document, do you just put it in the question spot, or do you just still email you?
You can email. You should email it to me. So I will not check that document like daily, but I check my email daily, right? So email me the question, and then I'll put it in the document. Does that make sense? Sweet.
Are we doing Learn Stories still?
It is over. It ended November 22nd. The winning class will find out that they were the winning class after everyone has caught up on their practice work. I love how like 12 of you are still just hanging out. You guys anyone got any good jokes? Thank you guys. You rock.